Hi, guys, let's just see this question again. A question that some of us are finding really difficult, but in my opinion, this is not really very difficult if you just pay attention to either one of the two concepts that I'm going to discuss with you. So let's quickly see how many positive integers less than 500 have remainder 1 when divided by 7 and remainder 2 when divided by 3. So how do we write a number n in this form? Remainder 1 when divided by 7. So I can write it in the form of 7a plus 1. And because it leaves remainder 2 when divided by 3, so I could also write it as a multiple of 3 plus 2. Now I know because I'm talking about the same number, so I just place this equal to sign with these two numbers. The question is we have to find how many such numbers do we have which are less than 500. So let me quickly discuss with you the method 1. Method 1 is something that is non-mathematical, but I really like this method. So please, let's just try to understand. What I do in this method is I simply start writing a few numbers that satisfy these conditions, right? So I just start writing which are the examples of numbers which when divided by 3 leave remainder 2. So I start from 2, the next number is 5, the next number is 5 plus 3. So what I'm doing is I'm just adding 3 in every previous number to get the next number. Then how did I get the first number? By placing b equal to 0. So 2, 5, then I have 8, 11, 14, 17, 20, 23 and so on. So I can just keep finding such numbers 23, 26, 29, 32, etc. But since there are multiples of 3, so there will be too many, because in just 100 numbers only you see 33 multiples of 3. So let me just focus on the multiples of 7 plus 1. So if I place a equal to 0, I get the number 1, but no, that's not what we want. Then if I put a equal to 1, then I get the second number 8. Now every next number I can get by adding 7 in the previous number. That means the next number will be 8 plus 7, that is 15. 15 plus 7, so the next number is 22. 22 plus 7, so the next number is 29. So that way I can keep going. 36 plus 7 is 43, 50, 57, etc. Right? Now let me just start looking at if there is any common number that I have been able to arrive at so far. So the answer is yes, this is the first common number. Let us see whether we have any other common number available here. So the next number is, that is common, what do we see? We see 29 is the next common number, right? I did not write enough numbers in the second column, otherwise I would also have encouraged you to find the third common number. So let me just quickly write down some more numbers and then see what is the third number that may be common. So 32, after 32 we have 35, 38, and then 41, 44, 47, 50, 53, 56, 59, etc. Do we see any number common so far? So the answer is yes, we do see a number common, and that is 50. Why did I do this? Because any pattern can be established if you can find out just 3 instances in that sequence. And now we have been able to find 3 numbers. First is 8, second is 29, third is 50. So if I were to tell you that these numbers are in a certain sequence, can you find out how the sequence is progressing? Then you'll see that the second number is 21 greater than the first, the third number is again 21 greater than the second. That means the series is progressing as an arithmetic progression. That is why I said that there are 2 ways to answer this question. So you can use the arithmetic progression concept here in mind. Since every next term is being achieved by adding 21 to the previous number, what is the logic of this 21? The reason is that in the first column, every 2 numbers have a gap equal to 7 or a multiple of 7. In the second column, the gaps are multiples, the gaps between any 2 numbers are multiples of 3. So here we say the numbers are at a gap of multiple of 7. Here we say the gaps are at a multiple of 3. So the number that are common will be at a multiple of 7 as well as 3, and we see that LCM of 7 and 3 is equal to 21. That's the reason why this is this kind of a series. So now I have to keep going. Now I know that this is the arithmetic progression in which I know that nth term has to be less than 500, because we have the question how many positive integers are less than 500. So I can say that a is equal to 8. A is defined as the first term in the arithmetic progression, and d is the common difference. Common difference I know is 21. So I have to see Tn. Tn is given by the expression a plus n minus 1 times t. If you want to just check it, you can go on my video of the arithmetic progression in the number properties playlist. You'll find it. Now, so Tn, that means a plus n minus 1 into t, 8 plus n minus 1, because I need to find out the value of n, because the question is how many such numbers. So n is the number of such numbers in this sequence. 8 plus n minus 1 multiplied by d21 should be less than 500. That means n minus 1 should multiplied by 21 should be less than 500 minus 8, which is 492. So n minus 1 should be less than 492 divided by 21. N minus 1 should be less than, now I have to just see how many multiples. So I'm just dividing 492 by 21. So 21 goes 2 times, it is 42. So the remainder is 7. Right, 42, 7 and 21 threes, 21 threes. So this is the maximum. That means n has to be less than 24. 23 point something, so 24 point something. That means n max can be equal to 24, and since we have n max equal to 24, so answer of this question becomes option C. So this is method 1. This is quite simple. Now I can also tell you the method number 2, but that is not really something I like, although it looks like very impressive to many people. So method number 2 is the algebraic method. That means we have the number of the form. Let me just change the color of my pen. So that is, I have 7a plus 1 is equal to 3b plus 2. So I can write it as b is equal to 7a minus 1 divided by 3, which means I can write it as 6a plus a minus 1 divided by 3. Why did I write in this form? Because this part is divisible by 3. So I want to make this part also divisible by 3, so that b also is an integer. What is the first value of a for which this part a minus 1 is divisible by 3? So the first value of a that you can think of is a equal to, you can place simply 1. So if a is equal to 1, this part becomes 0, and 0 is divisible by 3. For a equal to 1, what is the value of b? Let's just calculate. If a is equal to 1, then b will be equal to 2. You see, if you put b equal to 2 here, 3b plus 2, 3b plus 2 becomes 8. If you put a equal to 1 here, that means if you put n equal to 1 and or b equal to 2, the value of n becomes equal to 8. Let us see what is the next possible value of a that you can find here. So what is the next possible value of a? And then you'll be able to think that the next value of a will be 4. If you put a equal to 4, then b will be equal to 9. Why? 4 into 7 is 28, minus 1 is 27, divided by 3 is 9. If you put a equal to 4 here, 7 into 4, 28, plus 1, 29. That is the next number. You see? And if you put b equal to 9 here, b equal to 9 means 9 into 3, 27, plus 2 is 29. So again the same number. So 29 is a number. Now there is a pattern that you can see even here. What is that pattern? Let me just quickly show you. A is changing by 3, whereas b changed by 7. So what happens here is, that's for you to remember forever, that might be helpful for you, that whenever we have to find the solution of such equation, a always changes by the coefficient of b and b always changes by the coefficient of a, right? That means without putting so much of effort, now I know that the next value of a is going to be 7, and the next value of b in that case is going to be 9 plus 7, that means 16. The next value of a is going to be 7 plus 3, that is 10. Okay, 10, and the next value of b is going to be 16 plus 7, that is 23. So that way I can keep on finding the solutions till n is less than 500. Now we can use this logic as well and limit the n equal to 500. However, I prefer method 1, so I'm just trying to just make this video shorter. If you want to understand how this method completely executes, there is a link of the next video within this post only that you can refer to, and then you'll be able to understand how to find out the solution of an equation which are of this form. I hope you enjoyed the video because you learned 2 methods, and if you did, then please don't forget to like the video, don't forget to subscribe the channel. That can be immensely helpful for the growth of the subscriber of the channel. Thank you so much.